Thank you for joining me. This is the final exam review. So let's get started. Number 1 says which binomial is a factor of this polynomial. So you have 4 factors, and whenever you're looking for which one is a factor, you're looking to see which one is equal to 0. And in order to see that, you're always checking the opposite. So this one you're looking for 1, you're looking for 2, you're looking for -1, and you're looking for -2. Now technically you can plug those numbers in, but because this is a polynomial and you're checking multiple, you can actually go ahead and plug this into your y equals and check those numbers. So let's go ahead and plug this into the y equals, and obviously instead of g, we could go ahead and plug in x to the third. So I have x to the third plus 6x to the second plus x minus 14. And when I go to my table, I'm checking those numbers. I'm checking +1, and at +1, I do not see 0. I'm checking +2, and I do not see 0. I'm checking -1, and I do not see 0. And I'm checking -2, and I do see 0. So therefore, choice 4 is the answer. Okay, number 2, I have an imaginary unit, and I'm asking which one of these is equivalent. So we can use our equivalent trick, and whenever we have an equivalent trick, we have to store in a number. Now, right when you have your calculator, you should store in a number right away, and then you don't have to store in it again. So my favorite number is 10, so I'm going to go ahead and stow in 10. So 10, your stow is at the bottom left, STO, X. And right now my calculator thinks that X is 10. Is X equal 10? No, this is a trick. So what I'm going to do is I'm going to plug in the original, and it's going to spit out a funky number. And I'm going to plug it in exactly the way that I see it. Now the I button is all the way at the bottom. It's the decimal. I'm going to plug it in, and there you go. It gives me a funky answer. That is not the real answer. This is a trick. And now I'm going to plug in each option to see which one gives me the same funky answer. Okay, so far I do not have any of the same answers. Okay, and the last one. Okay, so the original gave us 96 minus 40i, and looks like choice 4 gives us 96 minus 40i. So therefore, choice 4 is the correct answer. Okay, number 3. Which graph has the characteristics of this domain and range? So X, your X's go left and right. So we're really just looking for the left side or the right side. And when you're talking about -infinity, that means left side. Now, f of x is really the same thing as y equals, which means that you're going up and down. So in this case, positive infinity means that we're going up. So we're looking to see which one, when you look to the left, you're going up. Well, if you look here, the left is going down. So this could not be the answer. The left is going down. So this cannot be the answer. So let's look at choice 3 and choice 4. We don't have a graph, so let's plug it into the calculator. So I have log. I'm going to press math, alpha, math, and I have log base 2 of negative x. And when I graph it, it kind of has this little hook to the left, and kind of looks like that. So when I look to the left, does it show that it's going up? Looks good to me, but I'm just going to double check with my last one. So when I have 3 times 2 to the x, three times 2 to the x, let's look at it. Okay, it looks like the left side is actually going down. Okay, so this looks like it's going like this. Okay, so choice 3 is the answer. All right. Raylan deposited $3,000 into a savings account that earns 3% interest per year. The exponential function that models this savings account is blah, 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 where t is the time in years, which the account correctly represents the amount of money in her savings account in terms of the monthly growth rate. So what's happening here is we are changing the rate from years to months. So in this case, we're not really focusing on everything that the equation is talking about. We're only focusing on this piece right here. And that rule is where you take that rate and you raise it to the 1 over the unit change. So what is the unit change? Well, we're going from years to months. So how many months are in a year? 1 over 12. Okay, now if you look at your multiple choice options, do you notice how option 1 did not even change? So therefore, I know that that's not the correct answer. So let's go ahead in our calculator and find the new decimal that's going to be inside those parentheses. So 1.03 raised to the 1/12. This is going to be our new decimal inside the parentheses. And the only option for that is option 4. And that also makes sense because when you change your rate, your new exponent becomes whatever your months are times t. And there you have it. Okay, now we can do this 2 ways. We can figure out what is equivalent, or we can do this the long way. I actually want to show you this both ways. So let's go ahead and do the equivalent way, and then I do want to very, very quickly show you the long way because this is kind of an important question. So I already plugged in x into my calculator, so let's go ahead and plug in all the options. So I have a fraction. I'm going to press math. I'm going to have the third root of x times, I have just the square root of x over the sixth root of x. All right, now I have a crazy answer, okay? And this is not my this might be wrong. This is not my answer choice. You know what? This might actually be wrong. Let's do this the long way. Okay. So, there's a rule that if you're in the inside, you are at the top of the list. So when you have an exponent and you don't see it, it's 1. When you have an exponent and you don't see it, it's 1. When you see an exponent and you don't see it, it's 1. And when you don't see the root, it's 2. All right, so let's change what we have here. So far, we have x. 1 is at the top of the list, 3 is at the bottom of the list. 1 is at the top of the list, 2 is at the bottom of the list. 1 is at the top of the list, 6 is at the bottom of the list. Now there's a rule when you're multiplying the same base. You're going to take these exponents and you are going to add them. So our new fraction is going to be 1/3 plus 1/2. 1/3 plus, 1/2. Which if I press math, fraction, I can get 5/6. Okay. Now on the bottom, I have 1/6. Now there's another rule that when you have the same base and you're dividing, you're actually gonna subtract those exponents. So now let's take 5/6 and subtract 1/6. And if I press math, I can change that to a fraction, and I get 2/3. There we go. And I do see that option there, and it is choice 1. Now, if I go back to my equivalent, I'm silly because I was saying to myself that this doesn't make sense, but duh, it doesn't make sense because x was 10. So let's double check that this answer matches what we just got, okay? So if I put in my calculator x to the 2/3, it does match that crazy answer. So that's how we know that it's equivalent, by checking. Okay? All right. Number 6. What are the roots in a plus bi form? A plus bi form automatically means that we are using the quadratic formula. Now, if you have a brain fart, I would choose any answers that have an I in it and a radical in it. Just saying. But the quadratic formula is given to you. The quadratic formula is x equals negative b plus and minus b squared minus 4ac all over 2a. And a, b, and c are the numbers in front of the x squared, the x, and then the last number. So a is just going to be 1, b is positive 2, and c is positive 5. So we'll go ahead and insert these. X equals negative 2 plus and minus 2 squared minus 4 times 1 times c all over 2 times 1. Now from here, you have to be careful because a lot of students try to plug in everything underneath that radical. You do not. The only thing you plug in are the numbers underneath the radical. So 2 squared minus 4 times a times c, which is negative 16. Now in this case, negative 16 is actually a perfect square. So what I'm going to do is I'm going to take this 2 and I'm going to put it underneath the -2. Oops. Actually, you know what? Instead of doing that, I don't want to confuse you. Let's just simplify -16. The square root of 16 is 4, and because it's a negative, I'm going to make it 4i. Okay? Now, this 2 belongs to the -2 and the 4i. So now when we simplify, 2 divided by 2 is 1, and 4 divided by 2 is 2. So I'm going to have -1 plus and minus 2i, which is going to be choice 3. Okay? All right. Number 7. Number 7 is a very, very, very popular question. I've told you many, many, many times. A recursive sequence has 2 things. Thing 1 and thing 2. So choice 2 is out because it only has one thing. Choice 4 is out because it only has one thing. So you have to look to see what is thing 1 and then what is the pattern. So are we adding or are we multiplying? Well, how do I go from 50 to 25 to 12.5? Well, technically we can be subtracting by 25, but the problem though is that if we were to subtract another 25, we'd be at 0. So therefore, it doesn't make sense that we're subtracting 25. So what does make sense? Well, if you do 25 divided by 50, you're having it. So this would be the correct answer because it makes sense that that's your common ratio. Okay, let's move on. Point 34 lies on the graph of the equation. Which point must lie on the graph of this? So you have to remember what your rules are. When you hug the x, you're going left and right in the opposite direction of the sign. So you're actually going to the right one. And in this case, you're actually going up 2. Now, you could do this 2 ways. Some of you do not need a visual. I love a visual, okay? So for me, I would actually go 1, 2, 3, 1, 2, 3, 4. This is just me. If you don't need this, that's wonderful, okay? But I would go right 1, okay? I would go right 1, and then I'd go up 2, okay? So if this point is 3, -4, and I went to the right 1 and up 2, wouldn't I be at 4, -2? Okay? Or, if you think about it, if you go to the right 1, aren't you adding 1 to the x? And if you're going up 2, aren't you adding 2 to the y? Which would leave you 4, -2. And there you have it. Okay, number 9. This will definitely be asked on the regions. A population is normally distributed. The second you see normally distributed, you know that you're working with normal CDF. Now, you have a mean of 20 and a standard deviation of 12. They want to know the percentage that falls below 19 to the nearest hundredth. So we are going to be working with a normal CDF, and you do not have to show all this work, but I'm just showing that these are the numbers that are going to be put in your calculator. And if anybody wants a little visual here, I have 20 in the middle, and I'm looking below 19. So if here's 19, I'm looking for this area here. So anything to the left is going to have a ridiculously small number. My mean is 20, and my standard deviation is 1.2. So to get normal CDF, it's second vars. So second vars, normal CDF. Now I know mine's a little bit different, but I'm still going to go in the same order. I'm going to go a really, really, really low number. I'm going to go to 19. I'm going to do my mean, and I'm going to do my standard deviation. And I'm going to get about 0.2 and to the nearest percent, I'm going to get about 20.23. And that is 3. Okay. Josie examines the graphs. She has 2 graphs. And what they then do is they set them equal to each other. Now, when they do this, they only want the x. So when you see this, do not put a point. A point has an x and a y. They do not want the point. They only want the x value. So in order to get your intersection, this is where you're going to do second trace intersect. Okay, so let's go ahead and put this in our calculator. We have 3 to the x minus 8, 3 to the x minus 8, and then the second one is the the absolute value of x plus 3. And to get to the absolute value, you're going to press math, num, abs. So math, num, abs. And then when you graph it, it's going to look something like this. Okay? Now my calculator is a little bit different than yours. I can't really calculate it, but when you do your second trace calculator intersect and you move your cursor to where they intersect, you should get 10.359. And ignore that y. And the 10.359 should be option. I was just going to say. Oops. There it is. 3dx. Hold on, let me just double check that I did this right. Ah, I didn't. Look what I did. I messed up. 3 to the x. Get out of that, minus 8. There we go. Okay, now that should make sense. So when you do your second trace intersect, you are only looking at your x, which is 2.359. Why do I still not see that? What is wrong with me? 2.359. Come on, buddy. N approximate solution. Is there more than one? Come on. All right, let's try this one more time. 2.359 Let's try this one more time. have to check that out because according to my calculations, it looks like it is crossing there. Okay, so anyway, I'm gonna have to double check that, but it looks like it's at 2.34. So I will have to double check that, but it looks like it's at 2.34. And I'm only looking at the X, so I'll have to change your multiple choice answers when I actually give this to you. All right, here we are to the free response. So solve algebraically. So this is logs, okay? And we talked about logs having three parts: a base, an exponent, and an answer. So your base is e. It's holding up the exponent, and your answer is 35. So the problem with this is that the 3 is doing absolutely nothing. And it's not the base because it's not technically attached to the e. So what we have to do is move it over to the opposite side. So when we move that over, and we get 35 divided by 3, we're going to get 11.6666 repeating. And I'm going to keep all those decimals. Now I have three parts. I have a base, an exponent, and an answer. Now when you put this into log form is bay form. You want to put the base on the bottom. Then you want to put your answer. And the whole point of this is to put your exponent by itself. So this is base, answer, exponent. Okay, now on the left side, you can plug that into your calculator. And if you want, you can even use ln. I'm noticing that most of you are putting the e into your calculator, which is totally fine. And if I scroll up, I lost it. It was 11. Where is it? Come on. 11.666. I'll just put a bunch of sixes in there. Okay? And once I get that, on my right side, I have to get the, oh, my bad. I put, instead of e, I have the x. I have to get x by itself. So whatever I get on that side, I'm just going to divide by 42.42. And that's what x is. And round it to the nearest thousandths is tens, hundred thousandths, so that's 3 decimals, so 5.849. 5.849, and there you have it. All right, number 12. They are asking you to write an equation like this. So this little -1, that's technically not an exponent, that is asking you to find the inverse. And when you are asked to find the inverse, you are asked to switch x and y. So don't forget, this f of x is really technically the same thing as f of x. So instead of f of x, I'm going to put y equals, and instead of x, I'm going to put y. All right. Now, I'm going to go ahead and solve for y. I'm going to write it like I read it. And technically, this is divided by 4. So The opposite of divided by 4 is to multiply by 4. Okay, now you can totally leave this like this, but usually they will actually do the multiplication. And when you do the division, usually they'll actually divide it by both. And you can leave this as y, but because they said write this equation, I'm going to actually put that back in like that. All right, number 13. This is a very, very, very important question. Mackenzie bought a pack of candy, and the manufacturer claims that 30% of the candies manufactured are red. Now, in her pack, 14 of the 60 candies, which are 23%, are red. She ran a simulation of 300 samples, assuming that the manufacturer is correct. The results are shown below. Based on the simulation, determine the middle 95% of plausible values that the proportion of red candies in the pack is within. And then based on the simulation, is this unusual that Mackenzie's pack had 14 red candies out of the total, which is 23%? All right, so the first thing we have to do is we have to find a 95% confidence interval. So in order to do that, that's going to be your mean plus and minus 2 times your standard deviation. So 2 times 0.58 is 0.116, and then we're going to take 0.301 and we're going to go down. So 185. Did they ask us to round? No. 2, and then let's go up. 417. So all that means is if I kind of look to find about 0.18, I don't know, maybe somewhere over there, and somewhere over there, all we're saying is that all of this inside we believe is considered usual. Anything outside we considered unusual. Okay? So we want to know, where is Mackenzie? Is Mackenzie inside or outside? So Mackenzie is at 0.23. So 0.23 is considered inside. So therefore, do we think it's unusual? No. Because 0.23 is inside the interval. Okay? All right. Number 14. This is the jewelry box method. Okay, now the good thing about this is that the jewelry box is already isolated. Now my advice to you is to put it in the calculator before you start for 2 reasons. Reason number 1 is that you'll already get the answer. So if you can't get the answer the long way, at least you'll get half credit. So I'm going to put the left side into my y equals. I'm going to plug the right side into my y equals. And I'm going to look at my table and I'm going to see if there's any values that are the same. So I can already get half credit just by doing this. And guess what? At the end, you're going to have to check this anyway. All right, so let's look at the table. And let's see. By the way, 2 and negative 2 are not the same. Oh, I see it here. 5 and 5. Okay, so it looks like at 6, 5, and 5, those are the same. So what is going to be an answer? 6. So if you just show this right here is going to give you half credit. Now let's see how we're going to get full credit. So once we have everything on one side, it's time to square both sides. And squaring both sides really just unlocks the jewelry box for us and lets us see what we have inside. But on this side, we actually have to multiply this twice. Now, if you want, you can do the box method, or you can go ahead and FOIL. Be careful with your signs. So this is x squared minus 2x plus 1. And now we're going to go ahead and start combining. Okay, now that everything's on one side, I'm going to go ahead and drop the first sign. A negative times a negative is a positive, and I'm looking for two numbers that multiply to 6. Well, I could do 6 and 1, or I could do 3 times 2. But those two numbers have to add up to a negative 5. So guess what? I'm going to do negative 6 and 1. So there's my 6, there's my negative 1. But guess what? We already checked it, and we knew that negative 1 didn't work. And there you go. All right, last question. The resting blood pressure of an adult patient can be modeled by the function below, where P of t is the pressure in milligrams of mercury after time t in seconds. All right, so we want to graph this. All right, so one of the first things I want you to do is to start with your shift. Now, they gave us a graph, and they gave us 90. So I know that I have to draw some type of midline at 120, and I know that I have an amplitude of 24. So let me kind of just get an idea just to see what my max and what my min are, just so I know how far and how low I'm going to have to graph this. So if I add this up, I know that I'm going to have to go to 144, and I know that I'm not going to have to go to 96. Okay, so if my highest is 144, I don't know, let's see, if I go 100, 110, 120, 130, 140, 150. Yeah, I'm going to go by tens. So 100, 110, 120, 130, 140, 150. And you could do any way you want, as long as it, oh my god, I am a silly goose. I forgot 110, 20, 30, 40. Okay. So now I know that 120 is my shift. And from there, I know that 96, somewhere over here, is going to be my lowest. And 144 is going to be my highest. Okay? Now, I know that I'm graphing two of these. Okay? And I need to figure out the length of one of these. So that is your period. So your period is 2 pi over b. And your b is 3 pi. So So your period is 2/3. That's going to be a little tricky. Okay, so 2/3 of 1. All right, let's see. If I break this up into thirds, okay, this right here is 2/3. Okay, so I need one cycle to end there. Okay, now once you know that, now you could go ahead and graph that cycle. And how many times does that cycle, how many parts does that break up into? 4. So 1, 2, 3, 4. And because this is a cosine curve, you know that you're starting high. So 1, 2, 3, 4, 5. So I'm going to go down and up. Okay, now another 2/3, if you think about it, that was 4 boxes. So another 2/3 is going to be another 4 boxes. And then I'm going to do it again. Okay, 1, 2, 3, 4. And then another 4 boxes. So 1, 2, 3, 4, 5. And there you go. Okay, so each one of these is 2/3. Okay, all right, now at the bottom it says determine the period. Well, we just did that. I kind of did that up top, so I'll just kind of reiterate it here. It was 2 pi over 3 pi. And explain what this means. Well, in this case, we are graphing the resting blood pressure. Okay, where P of T is the pressure in millimeters of mercury after T time in seconds. So that bottom is time. So we're saying that it takes 2/3 of a second for blood pressure for 1 revolution of blood pressure. So the resting blood pressure of an adult patient can be modeled by this function. So the pressure in millimeters of mercury after time in seconds. So this is 1 cycle of blood pressure is 2/3 seconds. And then the last part, we did that up here again, okay, because we kind of needed that. So we'll do 120 plus 24 minus 24. And the highest that we went was 144, and the lowest that we went was 96. And there we have it. Thanks for tuning in.